Sponsors have been fantastic. Without them, genuinely, this would not have happened. Capgemini and Oracle have been our platinum sponsors. BJSS are gold sponsors. And then IBM, Brightpearl, and Scott Logic are our silver sponsors. Do go and say hello to them. They're wonderful, and they've really made this happen. I will hand over now to Phil Bates from Oracle, who will introduce our keynote speaker. Thank you very much, and have a fantastic conference.
Hi everybody, I'm Phil Bates. I lead Oracle's Cloud Development Center in Bristol. I wanted to give people a bit of context for how we came together today. I've been working, as probably many of you have, in Bristol rather, for many years, right? I started working for Oracle in '99, building products for Oracle in Bristol. And, you know, like many folks, we focus on the work that we're doing, we're getting products made, etc. I work for a big American company. My head's been in California in many respects, although my body has been in this fantastic city in Bristol. And a couple of years ago, we started looking a bit more closely about, you know, the strength of the tech ecosystem around Bristol and Bath and the region. And we found something that really was quite exciting. This region has one of the most interesting tech clusters of people building cloud engineering, cloud products, and cloud software, right? SaaS, infrastructure as a service, PaaS. It's one of the most interesting clusters outside of the US. And the interesting thing to me is that people don't really know about it. We started connecting with other companies in the area, and we found something really quite interesting. Oracle's here, building cloud, infrastructure as a service, platform as a service products, business intelligence, data visualization, that kind of thing. HP have got huge investment in OpenStack, right, and storage and compute technologies, and also in data and analytics. Amazon, IMDb in the area, right? We've got IBM bought Cloudant, right, do cloud data services. So just in Bristol, we've got IBM, Oracle, Amazon, and HP, right, 3 large companies, and then there's a whole host of really interesting SMEs and startups. Brightpearl, we mentioned, building SaaS applications. We've got smaller companies like JetStack doing really interesting things with containers. Cray moved their EMEA headquarters right into Bristol to focus on high-performance compute. They've got a whole bunch of stuff around data analytics and visualizations and so on. Companies like Scott Logic, BJSS on the cloud services side. And then we've got the universities as well. Right, we've got Bath, Bristol and UE, all with significant student bodies and research bodies working around cloud infrastructure. And our incubators, right, places like Set Squared and Pervasive Media Studios, okay, that are spinning off startups, all focusing around these areas as well. Taken together, this picture is significant. And the interesting thing for me is I didn't know that 2 years ago or 18 months ago. Okay, I knew a little bit of it. And when I connected with people like Peter over here at HP, we found that Peter knew a little bit of that story as well. And we started to connect together between the different engineering leads of the different companies to say, well, if there is a cluster here, how come we don't know? And what do we need to do collectively, collaboratively together to start establishing Bristol and Bath as a world-class centre of excellence for cloud computing? Okay, and we started to work together. We started to meet every month, every 6 weeks or so to say, well, what really do we need to do as the companies, the universities, the incubators, etc., in the area to start really establishing Bristol as a place that people know if they're going to work in cloud computing, in cloud engineering, that Bristol is one of the places that you would come to do that. If you're going to study in software engineering, then you're going to know that Bristol is a place to do that. And we identified 4 things, very simply. The first is promotion. Because we didn't know that story, we need to start telling that story more frequently and more consistently. The second one is investment in the development community. We have a great development community in Bristol, but it's grown organically. Meetups are sometimes short of locations. They're short of good speakers to come into them. So by identifying the meetups, the companies and the organizations collectively can really start stimulating, make sure we got good locations, make sure that the meetups are supported with good speakers and so on. Bringing conferences to the town. Vox Days today is an example of that. We've collaborated across the different companies here, not just through sponsorship, but by working together to get programs together and all that kind of stuff to make sure that we have a really, really good high-quality conference. And we're looking at bringing DevOps, that's obviously today, it's the Vox Days conference. We're looking at bringing a series of high-quality technical conferences to support the development community. Supporting the incubators and the startups with infrastructure and resources and so on is the next one. So it really gives me great pleasure, right, that we've got Vox Days. There's so many folks here from the community together, and that Dave Cliff from Bristol University can open with our first keynote. So thanks very much, Dave. Thanks for being here.
Hi everyone. I thought to make it easy for you to recognise that I'm an academic, I would wear tweed. Tweed is really hot, and I don't normally wear tweed, so if you don't mind, I'll take it off. Thanks ever so much to Phil for that introduction, and especially to John for all the organisation work that he's put into this. Sorry, I forgot one of my gags. Look, there's no leather arm patches on this tweed because I'm not 100% academic, okay? I've been back in academia for 10 years now. So I've been at Bristol for 8 years. Before that, I spent 2 years at the University of Southampton. But before that, I spent 7 years in industry, working for Hewlett-Packard up in Filton, which is what brought me to Bristol, and it's a fantastic city. And working for HP was a fantastic experience. But then I got headhunted by Deutsche Bank and worked in the city for a bit, automating their foreign exchange trading. Now, for my sins, recently they needed someone to manage half the engineering in the university, and I forgot to duck. So I'm now head of the Merchant Ventures School of Engineering, which is, well, as its name doesn't make clear, is the school which embodies 3 departments: computer science, electronics and electrical engineering, and engineering mathematics. We have our own bunch of mathematicians who are specialists in mathematics as applied to engineering problems. So when I said the ivory tower, well, that's the closest thing that we've got up the top of the hill to an ivory tower. It's made of stone. It's not actually my department or my school, but the building behind it, that's the other half of engineering at the University of Bristol. That's the Queen's School of Engineering, which is, you know, they deal with physical force. They look at it's aerodynamic engineering, so your plane must fly; civil engineering, your bridge mustn't fall down; and mechanical engineering, your car must go forward. And just to the right of that shot is my building, the Merchant Ventures building. It's a lovely building. How many people have spent any time inside that building? Fantastic. This is good. How many people here are graduates of degrees offered by people in that building? A few. Fantastic. Good. So, when I say the Ivory Tower, what I really mean is Merchant Ventures School of Engineering. So I'm going to give a perspective on what we're up to, because as Phil so rightly said, I think there's a fantastic community of SMEs and of big companies, and there's a fantastic university doing some really interesting work, but I think we should talk more. I think if we work together more, and if we can interact more, we can just do more things and be even better than we are at the moment. So my school, as I just said, is 3 departments. It's roughly 100 academic staff, so lecturers, senior lecturers, readers, professors, about 1,300 students either doing taught undergraduate, taught postgraduate, master's degrees, or PhDs, postgraduate research degrees, and then about 200 people who are postdoctoral researchers, so they've already got their PhD and they're in doing advanced research. Almost all of us, but not every single one of us, are fundamentally concerned with either generating information from some physical signal, or manipulating or communicating or transmitting information, or extracting knowledge from information, or turning information flows, bit streams, into some sort of physical manifestation, like a display, for instance. There's a small number of us who do, they're called our Electrical Energy Management Group, and they basically do super advanced electrical motors, and they will get a look in right at the end of this talk, because it's important that they're part of our team as well. But essentially, almost all of us do information engineering, and I'd sort of secretly like it, or not so secretly now, I guess, if we could rename our School of Engineering to the School of Information Engineering, because I think that would be a better indication of what we do. So that was the Ivory Tower bit, but let's just briefly talk about the Bristol bit. And Phil touched on this, but I don't know how many of you have seen the latest Technation report, which was released earlier this month. So this is co-produced by Nesta and Tech City. They've done it every year for, I think, 3 or 4 years now. And there's a slight focus in their analysis on the SME sector, so that some of the data might be a little bit skew. But nevertheless, Bristol comes out of this really spectacularly, fantastically well. So here's kind of top 5 under digital turnover, digital growth in digital turnover, digital jobs, productivity, which is sales per worker, and salary growth in the UK on the basis of a really big survey. N is very large here, and look at where Bristol shows up. We're second on digital turnover in total. Sorry, we're third. Me and my eyes. We're 5th on growth in turnover. We're 5th in terms of the raw headcount of people who are involved in digital technology companies in the digital cluster. Sorry, this is Bristol and Bath. But perhaps most crucially, and the thing that I would contend is most attractive to potential employers or companies thinking of locating here is that our productivity is highest in the UK by their metric. And not only that, it's almost 50% higher than London, which is the next nearest. So we, by which I mean you, are really fantastic. And the way that the government is organising investments, if you think about the Northern Powerhouse, we should be thinking in terms of trying to collectively put our weight behind trying to become a southwest powerhouse based in Bristol, I think. And these kind of technology companies, of course, IT or computing or cloud computing is not the only technology companies, the only technology sector that is based in the Bristol area, because we've got a long tradition of aerospace engineering, for instance. But we should be working towards trying to get Bristol on the national map and the international map. And the best way of doing that, I think, is for big companies, small companies, and the public sector, by which I mean our university, my university, University of Bristol, UWE, Bath. There's also a slightly wider southwest coalition of universities, which is called the GW4, that I'll mention later. We should be working together. So I'm just really pleased to be invited here. Thanks very much for having me, and I'm going to talk mainly about stuff that I believe to be relevant to cloud development. I don't have a lot to say about Java because although I'm a professor of computer science, I've never written a Java program. Sorry. My language transition was something like Z80, 6502, Basic, Pascal, C, and then C forever. At C# when you move into the city, and then in recent years Python and Clojure and JavaScript. Fantastic. Anyway, so what I want to do is talk a little bit about the tuition that we give our students, because we have fantastic students, and I would like the local community of big companies and small companies to be more involved with the education we give our students, because Bristol is a really sticky city. When people come into Bristol to study, they very often don't want to leave because they like Bristol so much. And so one of my jobs, well, at least half of my job, is to ensure that the education that we give our students in the computer science department is appropriate to the kind of talent that you want to hire. And the only way I can really know for sure that that's the case is by looking at where people end up working and by talking to people like you. So I'm kind of hijacking the next 10 minutes or so of this talk to do a little bit of market research. I'm going to tell you what we teach, and then at the end you can say, that's really rubbish, or that's really good, or have you thought about adding this and dropping that? Then I want to talk about some data-intensive research projects, because you see, I think with cloud computing, the mathematicians have done quite a clever job. So you may have noticed that we've now got a national institute for kind of advanced data science, which is the Alan Turing Institute. It's based at the it's based at the British Library, and it involves 5 leading universities in a consortium. But when you look at the people involved there, it's largely mathematicians. It's essentially, I think, and here I'll choose my words carefully in order to be diplomatic towards my mathematical colleagues, they've kind of said data science, analysing data, well, that's kind of statistics, isn't it? So basically data science is maths. And yet when you look at the technology behind the technology that is enabling the data science revolution comes from computer science, I would contend. Things like MapReduce or GFS or Hadoop or HDFS or Spark or Pig. All of those things are computer science developments which allow you to ingest vast amounts of data which would have taken years or perhaps decades to ingest if you had tried it on old technology 15 or 20 years ago. You can then process them at speed using parallel computers and parallel processing algorithms which have been developed by computer scientists, and then you can spit out all the data and draw a graph, which is what mathematicians do. So with slightly tongue-in-cheek there, I think really the data revolution, the data science revolution should be recognised as something that we have delivered to society in much the same way as we delivered, we computer scientists, computer systems engineers, have delivered revolutions like the internet or the PC or the mainframe before that again and again and again. So I want to talk about some data-intensive research projects which are underway in the school that I'm head of. There's a lot more that I could talk about at the university, but I just don't have time, not without just doing everything very, very superficially. And then I want to talk about something which, so in particular, when I talk about those data-intensive research projects, I'm going to talk about 2 of our big bets at the moment. One is a project called SPHERE, which stands for Sensor Platform healthcare in residential environments. And it's a kind of internet of things for generating huge quantities of data, for managing an aging population that needs healthcare in its homes rather than in medical institutions like hospitals or care homes. And then we've also got this big project called Bristol is Open, which is actually a collaboration between the university and the City Council. It's been funded with tens of millions of pounds. It gives us ultra-fast wired and wireless across the entire city, and that's live. That was deployed in the last 12 months, and there's a tale to tell about just what fantastic things we can do, especially when we link those two together. So the joining it all up bit is slightly more speculative. It's me talking about a project that we haven't yet fully got funded or fully got initiated, but to give you a sense of the kind of thing that we like to do. So let's talk about teaching cloud. So we have, like all universities, we have obscure unit codes, and the unit code for my cloud course is Comms M0010. It's a master's level unit, so it's taught to MSc students and to final year students who are doing a 4-year MEng, Master of Engineering degree. So they come in at age 18 or 19, typically, do 3 years that would lead to a BSc, but then they do a 4th year, which is a project. This unit has been running in its current form as a standalone unit for 3 years. Before that, we had it kind of hidden inside another unit, and it started with one lecture on cloud computing about 10 years ago, and then it went 2, 3, 5, 8, 10, and then we just thought, oh, screw it, let's start a new unit. It's a final year option this year, but we're currently in the process of moving it into our 2nd year. Because one of the things you'll see when I give you this overview is that there's so much to say about cloud computing that in order to fit within the nominal 100 hours of study that a single unit in a university is supposed to take, if they don't know anything about cloud computing, you have to give them breadth before you can give them depth. So this is going to become a 2nd year unit, and then our final year students, having taken this as a 2nd year unit, will do Cloud 2 or Advanced Cloud, where they can go into a lot more depth. So, as you might expect, the introduction lecture is an introduction and overview, and what we get them to do there is to familiarise themselves with Nick Carr's book, The Big Switch. Anyone here read The Big Switch? Not very many. For those of you who haven't, it's a bit old now. It's coming up for about a decade since he wrote it. But it is fantastic. When you go on holiday, if you haven't, if you've read the complete works of John Grisham or the complete works of J.K. Rowling, buy yourself a book by Nicholas Carr. Buy yourself, in particular, this book by Nicholas Carr. It was particularly prescient at its time. It's divided into 2 halves, and the first half is the story of the centralisation of the generation of electrical power in North America from 1890 to 1922. How exciting is that? But the reason why he tells that story is because he draws the analogy between what happened in power generation and power distribution in the 1890s to the 1920s and what is now happening, or in fact, if you think about it, this is the best part of a decade old. So essentially, a decade ago, he was predicting what we're seeing now. So it's a remarkably prescient book. But he says that, in the 1880s, 1890s, when electrical power first became significant in industrial production, every factory, every unit of production had its own generator and its own generator support staff who would help you generate electricity that powered the motors, that was replacing the horses walking around in a treadmill or the water wheel or the windmill or whatever was previously turning your wheels. And that's not a very efficient way of doing it. So then there was this fight between Edison and Westinghouse, noticing that economies of scale meant that if you built huge stations that generate vast quantities of power, as long as you have a reliable, high-speed transmission network, you can deliver that power to the users and just charge them on a metered access basis. And the marginal cost of producing the power is very, 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 very low. And I think, hopefully, I don't have to point out explicitly that that's really quite similar to what's happening in cloud computing. Okay, I'll point it out explicitly. So, big data centers, lots and lots of compute power, accessible via a high-speed, high-bandwidth transmission network, the internet, metered at the point of usage, in principle, and the marginal cost of me using any one machine or virtual machine in a data center is so small that in comparison to the world of 10 or 20 years ago, I now have almost a kind of infinite supercomputer power available at almost zero cost. The second half of the book then talks about a whole bunch of predictions, some of which have almost come true, some of which are probably a bit off beam. The last one about Google trying to take over the world with AI, I laughed at when I first read it. Now I don't laugh. So that just familiarises our students with the kind of the historical picture, the economic drivers, why it makes perfect economic sense if you're a big cloud, if you're a big cloud provider to be in that business, and how it massively lowers barriers to entry that previously were really quite prohibitive. So we tell the story of Animoto, which is Jeff Bezos's kind of poster child for using AWS. Then you would think, okay, if you structure this course appropriately, what you should do is start with the warehouse full of computers, just talk about how you architect a big warehouse scale machine, then talk about virtualization, then talk about IaaS, then PaaS, then SaaS, and then go up the stack. However, we assess our students not on the basis just of an exam. The assessment is 50% exam and 50% coursework, a programming project, where in brief, the brief is do something cool in the cloud that you couldn't do client side, or you couldn't do just with a client server architecture. So do something that shows that you get scalability and elasticity of supply in the cloud. And in order to give them a fair run at that, what we actually do is we introduce a couple of platforms first before we go back to the start of the stack, before we go to the below the IaaS level to look at virtualization and the hardware. So the first thing we do is we give them a whistle-stop tour of AWS. It's one slide, it's one lecture. There's a slide in there where I show the prices for all the different AWS instances, and I've updated that slide every year for something like 8 years, including when the number of instances has exploded. And so one of the things we can show is the really astonishing drop in the price of AWS instance rental over the last half a decade or more. We primarily introduce students to AWS because AWS's free tier gives the best terms for our students to do their work, because essentially you get unlimited free usage, whereas on Google App Engine you get free usage for 2 months, and our course from start to submission of the coursework is about 3.5 months. So GAE is not so attractive. However, because these are master's students and some of them are coming in on conversion courses, we can't assume that they necessarily want to do all the low-level sysadmin wrangling that you have to do if you're a kind of heavyweight AWS user. So when this course first started, we advised people to use Google App Engine, GAE, which is the topic of the third lecture. And over the past 5 years, as many of you will be familiar, AWS, which started as IaaS and not much else, has with the things like Elastic Beanstalk, has become more and more like PaaS. And Google, which started as the App Engine very much PaaS, has moved down into infrastructure as a service with Google Compute Cloud. Is that what it's called? Can't remember. So I'm a bear of little brain. I like O'Reilly books. I like O'Reilly books for 3 reasons. They're well written. They're cheap. And they have a nice picture of an animal on the front. So I tell my students to get used to looking at O'Reilly books. What I should do is be sponsored by O'Reilly, but I'm not. So memo to self. So we talk them through AWS in lecture 2, Google App Engine in lecture 3, and then we talk them through the project assignment, which in the last couple of years we've been able to say, here's some exemplar project assignments from previous years, and just look at how amazing the work that the best students have done. So we only show them the stuff that's scored 90% or more, but our students are amazing. I have to work really hard. There are big, bold characters, bright red flashing letters on the first lecture and in the fourth lecture saying, do not work more than 50 hours on your programming project. And every year I get them to say, how many hours will I work on my programming project? And they'll go, 50. And then they're lying. They're lying. They work all the hours that God gives. They're allowed to work individually or in teams of 2 or 3, and they produce work that, frankly, I couldn't produce. They're better than me. And it's a joy to work with them. And I would suggest, if you're looking for talent, that you maybe come and knock on our door, because we attract brilliant students and we train them as best as I can, and they do brilliant things. And then we reset. Okay, so then we say, okay, let's talk about warehouse scale machines, for which the standard, the only really compelling text is the second edition. The first edition was just by Barroso and Holzel, and then Klideras joined them. So these are Google engineers talking about what it is to actually build a data center for Google. And they talk, in case you don't know about this, they talk about the only way that it works as engineering is to think about the entire warehouse as the machine which produces some number of web services, which enables some number of web services. The fact that when you then open it up, and in that warehouse, the individual components are racks of servers, and individual servers are computers with chips, that's by the by. That's like saying when I open up my car, there are different cogs, or there are different spark plugs, or there are different computers. But they talk about this very holistic approach, and it talks about thermofluidics, so how you manage cold air, hot air. It talks about power generation. It talks about the kind of raw architecture of the network, and it's the only way. One of the problems that we have in academia, but I believe also, I mean, from my time at Hewlett-Packard, it's also true in industry, is that when you're working in cloud provision, you're in a situation where your production environments are orders of magnitude bigger than your development environments. I mean, when I first went to HP Labs in 1998, it was easy. We were making a lot of money from printers and from ink, and there would be a lab with a printer in it. The lab was bigger than the printer, and that was kind of significant. But then when you start designing data centers with 50,000, 100,000, 2 million servers in it, you haven't got a test bed, you haven't got a production scale test bed to work on. So you're having to work on much smaller development environments and hope that they scale up. And some of the scaling lessons that these guys learn are captured in that book. And you only learn it when you build it for real. So this is the first hint that although I work in a university, I'm very mindful, especially talking to an audience like you, that university research is not necessarily the leading edge of cloud computing. Okay? The leading edge of cloud computing is largely dominated by big industrials like Google, Amazon, well, especially Amazon. The latest Gartner report late last year is that if you take Amazon's AWS infrastructure and add up all the other cloud infrastructure on the planet, Amazon's is bigger. So Amazon are clearly the leader. Microsoft, IBM, all the Oracle, of course. Big guys have moved into this wholesale. But the other thing is the agility you have working in an SME means that you can often solve problems or identify problems and then solve them on timescales much faster than university researchers can. So I'm not actually here to sell you a shed load of university cloud research, because I subscribe to the view that for some areas of technology research, especially that which is close to the market, the best place for it to be done is in the private sector rather than in the public sector. Now, that's not to say that I don't want public sector funding for universities to do research for stuff that's lower levels of technology readiness or further from the market. But one reason why I'm so, well, I guess the word is honoured. I'm honoured to speak to you lot, is I know that you lot are pushing things forward faster than academics are. And it's important to recognise that. So we talk to them about warehouse scale machines, and then we get academic for a couple of lectures. And here there is no book. Well, maybe a book has been written, but probably you would die of boredom proofreading that book, which is why it's never been published. So, So we talk about the Byzantine generals problem, which is a theoretical problem in distributed computing. How do you know that your system is trustable when you have noisy and perhaps malicious subsystems interacting within your system. So this is a graphic from one of the lectures, or the lecture that we give on Byzantine generals, which is given by my colleague Seth Bullock, Professor Seth Bullock. And then we also talk about Paxos, and I looked for a graphic on Paxos, and I couldn't find one. But I remember that there's stuffing called Paxo, and by the power of PowerPoint. That's my Paxos graph. And the reason why we talk about Byzantine generals is you don't really get Paxos unless you know BGP, and you need to know about Paxos because Chubby, which is the distributed lock mechanism that Google use, is based on Paxos. Also, our students like some theory every now and again. Then we go back to talking about virtualization, so we concentrate there on Zen. Then we look at containers and microservices. 3 years ago, there was no lecture on containers. I hadn't heard of Docker. Linux containers I remembered from 19-something, a long time ago. Of course, containerization has exploded, and microservices again in the last 18 months or so, and so we do our best to keep constant. Then, because there are no prerequisites for this course, and we have some people coming in from physics backgrounds or from chemical engineering backgrounds, we give a one-lecture summary on traditional SQL relational database management systems, and I'm not going to bore you with books on that. There's thousands of them. And then we give a lecture for which there's currently no book, which is, so this is based really on analysing the key papers published by Jeff Dean and his colleagues from Google, where I think it's remarkably public-spirited of Google that their engineers are allowed to publish in the public domain sufficient detail of what they've done that it's enabled, it's set on fire the whole kind of Hadoop ecosystem. Because the chances are, if they kept it a commercial secret, we wouldn't have Hadoop, we wouldn't have HDFS, we wouldn't have HBase, and so on and so forth. So Google's core technology looks at Google File System, GFS. It looks at Bigtable, it looks at MapReduce, it looks at F1, and then it looks at Spanner. So really it's just looking at the whole range. Of course, F1 and Spanner don't really have correlates in the Apache system, mainly because I forget now. It's been more than 6 months since I taught this. But which is the one that's got the geosynchronous atomic clocks that are all synchronous? Is that Spanner? Yeah, okay. So until such time as Apache sets up a global network of geosynchronized atomic clock-enabled server farms, Spanner's likely to be more of a Google thing than an Apache thing. Then we look at the Hadoop ecosystem, and I bet lots of you know about that, so I'll just flash up some books. We draw on all of these books, including two that do not have pictures of animals on. Because, of course, Hadoop has matured in an interestingly different direction from that kind of core Google stack with Hadoop 2.0 and Yarn and Tez, coming into play. Then we look at databases in the cloud, and Mongo, Cassandra. Essentially, it's a one-lecture summary of NoSQL databases in order that the students can, if they wish, use Mongo or Cassandra or any of the other such technologies, and it contrasts with what we teach them in Lecture 10. Then we do one on graph databases, so Apache Kafka, Pragle, Giraffe. Then we talk about HPC in the cloud, which is really, my view of HPC in the cloud is parallel algorithms. Parallelization is the only way forward in terms of getting multiple order of magnitude speed ups that we've become used to from Moore's law, but which are surely going to not be so frequent as we hit the atomic resolution limits of what we can do on established silicon. I mean, in my school, half in my school and half in physics, we have a huge quantum photonics, quantum computation group who in about 10 years' time will probably totally change Moore's law. But for the meantime, for the next decade, if you want to do really fast high-performance computing, it has to be massively parallel, GPU, and of course Amazon rent out GPUs, so we give the students a lecture on that. The other way of doing things really fast is in-memory compute, so Apache Spark and Shark before that, so we give them a lecture on that. Then we give them a lecture on economics and cloud pricing, because that's kind of what I know about, because historically my personal research has been kind of computational finance, and when I was at HP, and subsequently I've done work on looking at different ways of pricing or different economic models for providing cloud computing, and how with different economic models you can incentivize users to use the cloud provision in different ways, or indeed you can incentivize providers to provide in different offerings. We touch on stream processing, we look at cloud security, and then we give them some revision. Which is typically a mock exam. There's no good book in cloud security because cloud security moves very quickly. So there's not really an incentive to write a book, because by the time you've written it and it's gone through the printing presses and it's on the shelves, it's out of date. So we tend to rely there much more on recent academic papers or reliable weblogs. This is the plan, and then every year I disrupt the plan by talking to my friends in industry, and I can recognise one or two of them here: Peter Toft from HP, Phil from Oracle, and so this year we had Phil from Oracle, we had Peter Toft from HP, we had Peter's colleague Mark Watkins from HP Cloud Storage, and we also had an ex-PhD student of mine, a guy called Owen Rogers from 451 Research. And so what we do is we just kind of, this is a screen grab from the unit web page where we essentially rejiggle the end of the last 4 weeks of the schedule in order to accommodate people coming in from industry. And our students love it when people like you come in and tell them what's really going on, real stories from the coalface. Even if it's just a series of disaster stories, or a series, or even if it's almost, but not quite, corporate promotion. So, I mean, I, as an academic, I have a slight tension here in that I have to provide 20 hours of lectures to my students, and there's much more than 20 hours of content that I'd like to give them. So, in fact, what we do is we migrate some of the stuff that's me talking onto Vimeo or YouTube video lectures in order to make space in the 20 hours of contact that we're allowed for visitors from industry. So, beg number one. If you'd like to give a guest lecture as part of our cloud unit, you'd be really, really welcome. So I'll put my contact details. Oh, I think you get a copy of all these slides as well. By the way, I don't have copyright clearance on any of the images that I've used. Just thought I'd like to point that out. But I'm not being paid for this talk, so I think that comes under fair use. Anyway, so let's move swiftly on. So in most Western economies, we face a situation where the demographics do not look good. There are bulges in demography, which mean the baby boomer generation is getting older, and as they get older, they get sick, they're infirm. The cost of providing human care for them in institutions such as care homes or hospitals is very high, and if you draw some scary graphs out a few years, decade and a half, they get prohibitive. And furthermore, most people actually would rather be at home than in hospital. So my colleague Ian Craddock, working largely in the University of Bristol, but also with colleagues at Reading and at Southampton, has what is currently the biggest public funded research project in the country in computer science. This is this thing called Sphere, sensor platform for healthcare in a residential environment. The idea is that we decorate your home and your body. Imagine, I am old. I am. Next birthday's a big one. So I'm going to be 50. And soon enough I'll be 70, and then I'll be 80, and then I'll be infirm because I ran too many marathons and yada yada yada. So, but I want to live in my house. So what happens is these people come in with their technology and they decorate the house with small Internet of Things devices. So it's not a big server whirring away. It's a bunch of individual devices where each device doesn't need to be finely calibrated by an engineer. I can just put one on my shelf, or put one at the top of my stairs, or put one at the bottom of the stairs. And each device just does its own little job. So they're kind of individual specialists. So for instance, the thing at the top of the stairs might be watching me. It's got a video camera running, and it's not streaming the video anywhere because it's doing all its analysis on board, and it's just watching me go up and downstairs every time I go upstairs or downstairs. But it's doing a couple of things. One, if I fall, it recognises that I falled and it sounds an alarm, especially if I don't get up. And the other thing is it relays data on my gait back to some central server, where that gait analysis is analysed on the back of historical data that's particular to me, because all of us have our own individual gaits, because we all have non-identical body and muscular structure. So it compares my current gait to previous gait, and it might say, well, Dave, I think you're getting a bit of arthritis in your left hip, or you seem to have a problem with your right foot. That's one example. It's also possible to, I still wear an analog watch, but surely in time many people will be wearing smartwatches, and that smartwatch can interact with a body area network in order to monitor various biometric signals, but also location-based stuff in order to identify when I need a health intervention, or the extent to which an existing health intervention is doing useful things. This project has been underway for 2.5 years. The university, as you would expect, owns various bits of property around the city, one of which is a terraced house that was previously rented out to students, and now we've instrumented it. So when I say we, I mean they. So my brilliant colleagues. So Ian and his team have instrumented that house. The house is pouring out data. We're getting terabytes of data per week at the moment into the university, purely because we are streaming the video in so that our video analysis people can tune the video. But essentially we shut down that pipe. Nevertheless, when it goes live, and it goes live properly in in just over a year's time, there'll be over 100 houses instrumented in Bristol, pouring data back into the university, where clinicians and social health care medics will be actually using that data for managing the health of the people in those residencies. So there was a public meeting down at Bristol only 3 or 4 weeks ago, where about an audience about this size turned up of citizens of Bristol who are willing to participate in that first trial. All the devices are small, cheap, you can tread on them, buy another one, costs no more than a Raspberry Pi, but they produce, when you're doing it citywide, they produce vast streams of data. And the only way you're going to be able to process that is using cloud-style algorithms. So that's not yet deployed, but the one that you may have heard about that is deployed is Bristol is Open. So many, many moons ago, when dinosaurs ruled the earth, there was a company called Rediffusion. And Rediffusion decided that cable television was the future. This is like 1978 or 79 or something like that. So behold, Rediffusion did go out onto the streets, and they did dig the streets, and they did lay ducts. And the ducts were good, for they were meant for cables that were thick. And then, behold, Rediffusion went bust, or something like that. And the City Council, because of the way the contracts were structured, the City Council inherited ownership of all the ducts. So basically, Bristol was dug up and enabled for cabling under its streets several decades before anyone thought about putting ultra-fast fat fibre along those ducts. And my brilliant colleague Dimitra Simoneadou, she's a force of nature, and if you want to, she gives the best talk ever, but she's super busy. So I'm a kind of stunt Dimitra today. She has led this project. She and her entire team came over from the University of Essex about 4 years ago. They do next generation, ultra high speed digital communications, so wired, fibre and wireless communications, both for next generation data centres. So we often have big data centre providers in Dimitra's lab looking at the stuff that will make the next generation of data centres an order of magnitude or 2 orders of magnitude faster in terms of their internal comms than currently. But also the entire city is now covered. The spend on this was about £35 million, and it's deployed. Largely it's dark at the moment because we haven't thought what to do with it yet. Okay. Just to give you a sense of how big this thing is, phase 1 is in place. I've got some, you are here, okay, so that's the watershed. For scale, this is Temple Meads railway station, where some of you might have come from. So it's about a mile and a half by a mile and a half of ultra high speed fibre through the streets, including crossing over onto the south bank of the docks. And then we've got, then we've got about 1,500 lampposts. So, I was told, because this is being relayed into another room, so I'm mousing on one of the lamppost icons, but they're scattered all over the city. There's 1,500 Wi-Fi, fourth or fifth generation Wi-Fi attached to, out of vandals' reach, attached to lampposts to give Wi-Fi coverage in addition to the fibre coverage. And this is phase 1. Later phases roll out as far east as Bath and as far west as Weston-super-Mare. It's attached to Blue Crystal, which is the university's high-performance computing supercomputer, which, depending on when it was last refreshed, is often in the top 100 or top 500 in the world. It's a really big, meaty set of machines. And Blue Peter, or Blue Peter, our petascale storage facility. Down here is the Data Dome. Anyone here heard of the Data Dome? Anyone here heard of Bristol Planetarium? They are the same thing. By day, the planetarium is the planetarium, and by night, when the customers have gone home, it becomes the Data Dome, which is, we've got it wired up, we've got the speed to provide real-time. So it's just gone digital. It used to be one of those old things that looks like a sort of dumbbell with lots of lenses on it, and now it's a set of coordinated 3D projectors, and you wear 3D glasses and you look up and you've got a full hemisphere dome to look into, and they can kind of say, this is the night sky, and then they can say, now let's look at millimetre wave radiation, and just flick it like that, and you get to see a projection of millimetre wave radiation across the same surface. Thinking about how we might use that for interesting projects is something that we're still working on. Okay, so we've got some ideas, and then the other thing is that all of this feeds into the Temple Quarter Enterprise Zone, and in particular the Engine Shed, which is a university joint endeavour for high-tech startups. And you might notice that there's a whole bunch of containers stacking up next to the old Engine Shed building, which is the expansion space, because that's just roaring success for tech incubator and sort of early stage SMEs in the technology sector in Bristol. So joining it all up, I've just been given you've only got 10 minutes left. That was about 5 minutes ago. I'll now tell you about a project which we're talking about in the consortium, which involves the 4 Southwest universities. So the 4 Southwest research intensive universities. So we get on really well with UE. We do a lot of stuff with UE. We have the Bristol Robotics Lab, which I haven't had time to talk about, which is doing fantastic things. But there's a separate collaboration we're in, which involves Cardiff, Exeter, Bath and Bristol. We go by the name of GW4, and me and my colleagues and sort of opposite numbers at the other 3 universities came up with this plan of using this thing, using the Bristol is Open fibre net, to do something about air quality. You may not know this if you're not a resident of Bristol, but there are EU mandated air quality limits on nitrous oxides and particulate matter from diesel engines, which Bristol routinely breaks. And the EU's plan, this I guess assumes that we're still in the EU by the end of June. The EU's plan is to progressively lower those limits, and they are bad for health. There are many early deaths attributed to high levels of NOx and particulate matter. So, build a whole bunch of low-cost, cheap, cheerful air quality monitors. You need also anemometers, and you need also traffic flow monitors. But you can do all of that with a Raspberry Pi and a shield on top of the Pi, and just cover the city in those. And it gets kind of confusing. So that's what all these red dots are. Let's get rid of the city. And then they all feed into some city traffic and pollution predictive simulation model. So this simulation model has a topological map of the city, like a 3D surface map of the city, down to building scale resolution. It also takes a feed from historical data, so that on a Monday in June, we have some historical data that tells us roughly what traffic to expect. We get data in from the Met Office to know what the weather conditions are like, and then we run Met Office style simulations, which involve typically just doing a shed load of simulations in parallel, and then taking some sort of collective view of all those parallel simulations, where the difference between each simulation is just some variation in the random number generator, so that any kind of chaotic effects ripple through. And then this thing basically will be able to predict where in the city there are going to be pollution hotspots and at what time. And then we can, one of my colleagues is Professor Eddie Wilson, who is extremely senior in intelligent transport systems. He spends an awful lot of his time at the Department for Transport telling them how to do intelligent rerouting and dynamic rerouting around cities. We can also talk to hybrid cars, and this is where the people that aren't doing information engineering in my school are the electrical energy management group, and they basically do the best electrical motors for hybrid cars. And the thing is, the next generation of hybrid cars will be smart enough that we'll be able to radio out to them and say, switch from internal combustion to electric because pollution levels are too high. Sorry, but you haven't got an option if you want to come into Bristol. Or, sorry, but you have to pay an awful lot of money if you want to stay on IC. So the cars switch away from internal combustion. And then the other thing you can do with the kind of technology that Sphere has developed is you can go out into the homes of people that are affected by negative air quality, and you can say, take your medicine. So here's an old chap taking some Ventolin. Or you can say, shut your windows. Or office air conditioning can be ramped up in order to deal appropriately with whatever situation prevails. So this isn't yet live, but Bristol is open, is live, so the network's there. Sphere is live, it's just not yet finished, and the rest of it we think we can do. And this was presented briefly to Sir Mark Walpert, who's the government's chief scientific advisor, and he likes the look of it. So the thing is that when you work, if I was just a computer science academic in one department of computer science, I wouldn't have access to the brilliant colleagues in electronic engineering. Ian Craddock and Dimitris Simoneou are both electronic engineers. Eddie Wilson, our Professor of Intelligent Transport Systems, is a mathematician in our Department of Engineering Maths. So in our school, the 3 departments combine to give a whole which is bigger than the sum of its parts. We can do these big bets. Then we can combine with other universities, Bristol, UE, Exeter, Cardiff and Bath, to do these big bets, which you couldn't do on your own. But imagine what we could do if we worked more closely with you. We could do really big things. There are sources of public funds that are available to me that aren't available to you, and there are some sources of public funds which are only available to me if I co-apply with people in the private sector. So we should be talking. You don't have to talk to me if you don't like the cut of my tweed waistcoat. I've got 99 colleagues that you should be talking to. Please get involved. We've got fantastic students. We've just opened a new institute of data-intensive research, which I had a hand in setting up, but because I'm busy with this, my colleague, Professor Bill Brown, is now running. As I said, our students love working on real-world problems. Our students would love to have industry mentors. We try and equip all of our students in our school with an industry mentor. It's group mentoring, so it's not particularly intensive from your perspective. But they're in the School of Engineering because they want to do engineering and they want to go out and change the world. They want to do interesting things in the real world. And the other thing, of course, is if you're looking for talent, our students very often seek employment in Bristol. So I'd just like to say thank you again to John for organising this, because I think it's absolutely fantastic that the high-tech Bristol and Bath CIC is up and running. It's great that we've got this SIG that Phil and Peter Toft have played so much, and also Roger Holmes, who I can't see where he is. But yeah, I mean, there's a real buzz about what's going on in Bristol that you don't get in other cities. And London is too big and too diffuse, and Hoxton is too, well, Silicon Roundabout is too full of hipsters. So on that somewhat critical note, I'll say thank you very much for listening. Okay, right.